If you want to get started into data oriented roles, there are several career options you can choose from. There's data analysis, data engineering, and data science. I have worked as a data analyst and a data engineering across multiple industries. In this video, I'll be focusing on the data analyst part, and in the upcoming videos, I'll talk about the other roles. As a data analyst, you'll be analyzing all of the data that comes through the organization and help the business make informed decisions based on the data. Now, the first question you might have is what is the data that is coming? So, this data could be in various shapes and forms. For example, let's say the business has started a new product and they are gathering details about how long people are using that product or for how long they've had that product or if they're returning the product. So all of this data is fed into the system and then you'll be making business decisions based on that so that the business could help improve the product. Another example would be, let's say you want to figure out where all of the users are located for your business or where the majority of the users are located. So in that case, you'll be figuring out based on data on where the users are, and then based on that, you can tell that to business, and then the business could make informed decisions based on that. And that's basically what you'll be doing as a data analyst, visualizing data to help the business make informed decisions. So the first step for data analysis is getting the data. The data will usually be there in Excel spreadsheets or a database. Now, if it is in Excel spreadsheets, you can import the data into any software wherever you want to visualize it. Before importing, you'll have to do some cleaning up the data. So this is called exploratory data analysis or EDA. In EDA, you will make sure the data is in the correct format for visualization. For example, let's say the data has a date column, and in that date column, you realize that the data is not in the correct format. At some places, the data has date and time. At other places, there is just date. And at other places, there's date, time, and then some other extra string attached. So in this case, you'll have to clean up the data. This is called EDA, where you'll analyze the data and then you'll perform some data wrangling operations. Data wrangling is basically where you clean up the data into a format that could be easily visualized, and whatever data is either missing or incorrect format, you have to correct it. You can do various operations on the data where you can find the mean, mode, or median of the data, or you can find the standard deviation or variance and then figure out what you need to do with that particular data. Basically, you want to remove the outliers so that all of the data is in a good format for it to be visualized. Because let's say if you have a lot of data between the numbers 1 and 10, and then there are two or three data points which are in thousands. In that case, once you visualize the data, it will look very weird. So you need to remove all of those outliers. So that's the first important skill you should have as a data analyst. You should be able to perform data wrangling operations or exploratory data analysis on your data. But where is the data coming from? Where is the data stored basically? So this data is usually stored in Excel spreadsheets or databases. If the data is stored in Excel spreadsheets, you can easily open it and then see what all things are missing in the data. If the data is stored in a database, then it could either be a relational database or a non-relational database. A relational database is a database which has some relations, and usually you need SQL to query these databases. For a non-relational databases, you need NoSQL to query the database. Most of the times, the data would be stored in Excel spreadsheets and relational databases. However, in some cases, the data could be stored in a non-relational database, and then you'll have to query that. For a relational database, you need to know SQL or structured query language. So using SQL, you can easily query all of this data and then figure out what is the data that is present. If the data is stored in a non-relational database, which is very rare, but it could happen, in that case, you'll have to learn the specific language for that particular database. So usually all of the non-relational databases will have a very similar but different querying language. So you analyze the data, you looked at the data and everything looks in the correct format. Then you queried it using a query language. Once you have all of this data, now you want to visualize the data. For this, you'll be using a software. Usually, Tableau and Power BI are the two most popular softwares. However, there are other exceptions that you could be using. All of these softwares are more or less the same, and what you'll be doing over here is connecting to the database or connecting to the Excel spreadsheet and then fetching all of the data into the software. Once you have all of this data in the software, you'll be visualizing it. So you'll initially start on by creating different sheets where you'll put on the x-axis what data you need and then on y-axis what data parameters do you need. Once you have all of the data in the software, you'll help improve the data visually. So you'll be doing some font changes or color changes. And once you have the sheet prepared, you'll be creating a dashboard. And this dashboard is where you can have a lot of different sheets combined. So let's say one of the sheets shows where are the top 5 regions where your data is coming from or where your users are located. Another sheet could be how much sales revenue have you generated in the past year. So a lot of sheets could be put on one dashboard. And the dashboard is basically the last step of your data analysis. This dashboard is then going to be used by business to make some informed decisions. And in most cases, the dashboards are going to be dynamic, which means that if you click on a particular field, the entire dashboard will change to show just that particular field's data. Let's say you want to see the data of the past 30 days. In that case, you could tweak the dashboard to change all of the different sheets to show the data of like the last 30 days only. In that way, it is a lot more easy to visualize all of the data compared to just looking at the database or the Excel workbook. Now, as a data analyst, it's good that you also add Python and R to your skill set because usually for EDA, it is easier to do the exploratory data analysis and data wrangling using Python or R language than to just go row by row and then clear up the data. So those two skills are important. And if you want to be more on the business side and you want to do less coding or be less technical, in that case, you could go ahead with a business analyst role. So the data analyst and business analyst are quite similar. The only difference is data analyst is more technical, where the data analyst will be doing a lot of data wrangling and then making the visualizations. Business analyst is more towards business. So they'll be looking at different metrics and doing more of the presentations and business facing work compared to the data analyst. In my career, I've had several data analyst roles, and I'll give you some examples of what I worked on. So at one organization, I was working the communications team, and they wanted to show a lot of data to their investors and funders. And most of the data was social media data or website data. And all of this data didn't really need to be visualized using a specific visualization tool because there are a lot of tools that could auto create all of the dashboards and reports for you. For example, Salesforce is one of those tools where you can import a lot of data and then it will automatically visualize all of the data. Another example is Google Analytics. Google Analytics will create a lot of dashboards for your website and it will show where all the users are coming from, what are the top pages the users are visiting, where they are clicking, and all of this data. If you are analyzing something, let's say like social media, in that case, there are a lot of tools. For example, Hootsuite, which will integrate to these social media APIs, the Facebook API, the Twitter API, or the LinkedIn API, and fetch all of the data directly. So you do not have to worry about EDA or cleaning all of the data. It will already be cleaned and be in the perfect format. You'll just have to visualize it. And the visualization is usually just dragging and dropping. A lot of places, example my school, they don't have a specific data analysis team, so they use these specific tools to visualize the data like Sprinkler or Hootsuite, and it's a lot easier to work with these tools if you do not want very specific visualizations to be made. Another example is for a product where I was working at. They had a new product that they were launching, and all of the infrastructure was on AWS. So for visualization, naturally, they went ahead with AWS QuickSight, which is another visualization tool, but it is entirely on AWS. So it was easy to integrate it compared to adding Tableau or Power BI in that case. and all of the data was also stored on AWS S3 buckets. S3 is non-relational in this case. So I had to bring all of the S3 data into a format that could be used by the QuickSight software. In that case, I had to do a lot of pipeline building, ETL analysis using some tools, and then bring all of the data into a querying tool. And then from that querying tool, I bought it and created dashboards out of QuickSights. For another organization, I had to do a lot of ED analysis because the data used to be in various different formats, and all of this data will be put into Salesforce. Now, Salesforce will automatically create reports or visualize all of the data, so I don't have to worry about visualization. But Salesforce needs very specific column names, and the data has to be in a very specific format. So for that, I had to do a lot of AD analysis and scripting and stuff. Basically, a lot of Python programming instead of the data analysis bit. But the last two examples I gave, I wanted to be more technical or more programming oriented in the data analysis thing, which is why I chose to incorporate a lot of Python programming in both of them. But usually, as a data analyst, you won't need a lot of Python programming. You just need a lot of SQL coding and visualizing software knowledge. So that's it. That's more data analysis. And then there's data engineering and data science, which I'll cover in an upcoming video.